Here we're going to look at one of the inequalities from 8.5. This is number 39. This is sort of like what I started doing in class with the pizza problem, where imagine we wanted to define how much space is inside our yummy pizza here using polar coordinates. So notice they've marked it because they've marked our axes as x and y, that they have marked things in Cartesian coordinates, and it's up to us to turn it into polar coordinates. So we, of course, have available the formulas that r is the square root of x squared plus y squared, and that the tangent, let's just write this as tangent of theta. Tangent of theta is equal to y over x. We write it this way, of course, instead of inverse tangent because we need to make sure that we're considering all possible solutions to this equation. In this particular problem, I do notice, however, that my theta, if I look at the angle of rotation, I always start from the positive x-axis, I can go as high as that point and down as low as that point, so theta is always going to be in quadrants 1 and 4. So since theta has to be in quadrants 1 or 4, which is in fact the range of inverse tangent, in this case we can think of theta as being the inverse tangent of y over x. This is an inequality because I want an expression that's going to tell me about this entire shaded area. Everything, not just that one little arc, not just each of those points, but everything inside. So I can start with a radius, we'll erase my shading here for a second. I can start with a radius as small as 0, and I can start with my radius as small as 0, and I can keep going out. I can have everything that's at this radius, everything that's at this radius here, everything from a radius of 0 all the way until I fill it out of this radius right there. So in order to find this radius, when I'm given x and y, we're going to use the very first equation that we have written up here. So that one, since in this case x is radical 3, r is the square root of x squared, radical 3 squared is 3, plus y squared, 1 squared is 1. So we have that r is the square root of 4, or r equals 2. So that means in order to shade in my region here, my radius can go anything from 0 all the way out to 2. So we have for our first inequality that r has to be between 0 and 2, and including those, because I have this edge is in a solid line. My arc is included in my graph. So r is between 0 and 2. Now we need to think about theta. So let's kind of erase here again and imagine try and visualize what's going on here with theta. When I think about theta, I think about my rotation. So I'm anywhere on here, and I can rotate up to here, and I can rotate down to here. So I'm trying to think about what's my maximum rotation right up here that gets me to 3, 1, and the minimum rotation that gets me down here to radical 3, negative 1. So I think I misspoke. This is, of course, radical 3, 1 up here. So that's where I'm going to use this formula, that theta is the inverse tangent of y over x. In this case, I am writing it as inverse tangent because, as we observed earlier, we noticed that our angles are in quadrant 1 or 4, which is in my range of inverse tangent, so I'm okay thinking of it that way in this case. So we notice that our maximum theta up at the top in quadrant 1 is going to be the inverse tangent of 1 over radical 3, right? Because again, I'll make a note here because I'm in quadrant 1, so I know it's exactly the inverse tangent of that, which of course is pi 6. That's my largest rotation, right? And a rotation of pi 6 brings me all the way up to this point. So I could rotate 0, I could rotate pi 12, so I could rotate all the way up until I get to pi 6. I can also rotate down. So I notice that point in quadrant 4, at that endpoint, theta would there be the inverse tangent of negative 1 over radical 3. Again, in this case, I can't express it exactly as inverse tangent because I can see that it's in quadrant 4. So the inverse tangent function would give me the answer I'm looking for, which in this case would be negative pi 6, thinking of that as a negative rotation. So in this case, again, I could rotate negative pi 12, negative pi 6 brings me all the way to there, and then I'm done. Be careful of choosing theta wisely because there are multiple possibilities for choosing theta. If you don't write it as the inverse tangent, you might say, oh, well, I could also get to that point if I think of tangent of theta of negative pi thirds, that's 11 pi 6. 11 pi 6, however, involves a rotation like this. So when we write our inequality, if I say everything between pi 6 and 11 pi 6, I am now looking at this part in purple. That would be my rotation from pi 6 to 11 pi 6. That's not the area that I want to shade. I want to shade here the area that we have in green that goes in between pi 6 and negative pi 6 to make sure that I get the correct slice of pizza, so to speak. So putting together what we've just done, we already said here that the radius has to be between 0 and 2. That gives me my pizza all the way out to the arc. And my theta, my angle of rotation, has to go from negative pi 6, so I'm starting at the bottom, up to a maximum of positive pi 6.